Hey guys, welcome to the 2A.2. So our second video for Target A. It is Mrs. Payne. Our master learning objective for this video is I can identify key features of a quadratic function by using technology. Okay, so we're going to be looking at some key features. One key feature, or I guess two key features we already know. Remember we learned our vertex form yesterday. Okay, so we can find our vertex as a big key feature. We also have this form here, which is standard form. Okay, and this is how you find the vertex. We're never going to worry about that too much. We'll usually use the vertex form, or we'll use a calculator, a graphing calculator, to find that. Okay. The other things we learned yesterday was, remember, if it's positive, so if it's greater than 0, it opens up, it looks like a smile. That means it has a minimum, and we'll look more at this later. If A is less than 0, it's negative. It opens down, looks like a frown. It has a maximum. Okay, so we can kind of draw those, right? If it looks like a smile, this vertex is the lowest point, we call it a minimum. If it looks like a frown, our vertex is the highest point, it's the maximum. Okay. Our x-intercepts are where the graph hits the x-axis. You can see them here. Draw. Right here and here, where it hits this axis. We will sometimes talk about the y-intercepts. I don't know what the computer's doing today, guys. I apologize. We will also talk sometimes about the y-intercept, right? Where it hits the y-axis. And then domain are your x values, how far right and how far left and right the graph goes. Okay, so if I look here, my graph is going forever this way and forever this way. So in most cases, or in all cases, our graph will go forever to the left and forever to the right. And we'll look how to write that. For the range of the y values, how high and low the graph goes, well, you can see we have a lowest point here, so it starts there, and it will keep going all the way up. Alright, so let's look at how we find some of these things. Alright, as a problem, I have all these different key features I would like to find. I don't really like the order that they're in. We can always start with the first one, the sign of the leading coefficient. Remember, it's either it looks happy or it looks sad. This graph looks like a frown. Okay. So a frown, is it positive or negative? It is negative. Okay. I'm going to skip the increasing and decreasing for now. We'll come back to that. Our x-intercept and y-intercept is pretty simple. It's just x-intercept where it crosses the x-axis. I have here at 1 and here at 3 is where it's crossing that x-axis. So that means it's going to be 1, 0, and 3, 0. Okay. My y-intercept, same type of thing, where it's crossing this y-axis, and that's here at negative 3, 0. Okay. I'm going to skip domain range again for now. Every time I try to change my pen color. Our next thing is our vertex. So that's, is it a max or a min? Well, it's the highest or lowest point. I don't know what's wrong. I apologize for the board. This has a high point, right? It's higher than the rest of your graph, so that means it's a max. Maximum, the highest, or the most. Okay. What is that point, right? The highest or lowest point is our vertex. This point I'm over 2 up 1. It is at 2, 1. Okay. now I'm going to look at increasing and decreasing and then domain and range. All I'm going to do is I'm going to draw two lines, dotted lines, one straight down the middle of my vertex, and one across my vertex. So basically, I'm splitting my graph up into these pieces. Okay? If I follow the x-axis, this side is negative infinity. It does go on forever. That's what that arrow means. Where the line is, it passes right through 2. And then this side's going to go this way forever, so that's going to be infinity if I'm going across my graph. When I'm going up and down my graph, again, the bottom is negative infinity. Where my line I just drew is, it crosses through 1. And the top is infinity. Okay? For increasing and decreasing, we are only going to be looking at the bottom. Okay? We're going to be looking across our graph. Okay? So I'm going to write that across. So both increasing and decreasing. Okay? When we're looking across, we're always moving left to right, just like you would read a book, right? You wouldn't start on this side and read that way. So we always start here and read this towards this side. So I'm going to look at this first group, negative infinity to 2. From negative infinity to 2, my graph is, if I go this way, it's going up. It is increasing. So how I'm going to write that is, I start at negative infinity. Negative infinity has to be less than whatever your x value is, which is less than 2. This is how you would have written it in Math 1. We are slowly going to move away from this type of writing. And I believe how we write it is easier in Math 2. I don't have to worry about this part. I just have to worry about my numbers. I'm starting at negative infinity, and I am going to 2. It looks like a point, but it's not. Okay? The parentheses just mean I don't actually ever reach negative infinity. At 2, it's neither increasing or decreasing. So again, it's not really increasing at 2. It's increasing until 2. So these parentheses here mean the same as a less than symbol. All right, let's look at decreasing. Okay? I'm going to look at this section of my graph. It's going down. It's decreasing. That's from 2 to infinity. Again, the way you would have written it before is 2 is less than x, which is less than infinity. Okay. Looking at the domain, domain is also across. Okay. Looking at the pieces I split it into for the domain, I just want to know, is part of my graph there? Okay. So going across. Looking from negative infinity to 2, yes, part of my graph exists between these two places. 2 to infinity. Yes, part of my graph exists between these two places. So what I can say is if I go from negative infinity all the way to infinity, my graph exists between there. Okay? So then we can write it as negative infinity is less than x, which is less than infinity. Or how we're going to write it, negative infinity to infinity. Okay, again, this is not a point. I know it looks the same notation as a point. It is called interval notation, not a point. All right, our range, same thing. Our range is the only one that's like the height. Okay, so where domain goes across, for range, we're going to be looking at height. And for range, we always go bottom to top. It is different than reading. Okay, you want to start at your lowest value and go to your highest value. So for the range, I'll look where my graph exists. If I look between these 2 points, my graph exists between there. If I look at these two, right, up here, there is no part of my graph, that parabola, that's between those. So we don't care about that. We only care about negative infinity to 1. So this would be negative infinity is less than x, which is less than or equal to 1. So I do have that point there. Okay, so our range will have an equal sign. How I'm going to write this is negative infinity, and then that 1 is going to have a bracket. That's only going to be for the range when we're talking about parabolas. And that's all our key features. Let's look at another example. All right, so again, our leading coefficient, is it positive or negative? Again, we're looking, is it a happy face or a sad face? This one looks happy, so that means that it is positive. So it is a happy face, it is positive. Alright, okay, we're going to skip increasing. Let's look for x-intercept real quick. Where does it cross? Crosses at 2 and 4. That the points are 2, 0, and 4, 0. This one has no y-intercept, so I'm not going to worry about that. Again, I'm going to skip domain and range. Does it have a high point or a low point? This is the lowest point, so it's a min. What is that lowest point? 3, negative 1. Okay. Now, domain, again. I'm going to split that and go negative infinity to 3 to infinity. I'm going to draw my other line. And same thing, negative infinity to, this is at negative 1 to infinity. Okay. So for increasing or decreasing, remember we go across. Looking between negative infinity and 3, I read left to right. This part is going down when I go from left to right. So it is decreasing. Again, we can just use these parentheses from negative infinity to 3. Again, that's what this is saying. From negative infinity to 3. This is not a point. Looking at my second half, reading left to right, it's going up. It is increasing from 3 to infinity. Our domain, again, our domain is across as well. I'm going from negative infinity to 3. If I look at this part of my graph is there. If I look at this part of my graph is between these lines. So my domain goes from negative infinity to infinity. Our range is the only time we look at the height. Negative infinity to the 1. Between these lines, I don't have any graphs here. Right, that's empty. Between negative and 1 and infinity, I do have my graph. So my range is negative 1 to infinity. Remember, with the range is the only time I'll put that bracket because I actually am equal to negative 1 to infinity. Alright, let's look at our next example. Our next example is just a function. It doesn't have a graph. So we are going to use our calculator to graph it ourselves. Alright, so looking at our TI Inspire calculator, which again, you can open on your own computer. Always start at home. This time I'm not going to calculate because I'm graphing something. So I am going to go to a new document. If it asks you if you want to save, say no. And then we're going to add graph. Okay? I'm going to put those instructions on our notes. Make sure we write that down. So off the side, we're going to say, new document, add graph. Okay. Our second step is to type in the function. Okay, this is our function here, x squared plus 5x plus 4. So I'm going to type that in. X squared plus 5x plus 4. Okay? When you type it in, you should get a graph that looks like this. This is my parabola. Okay? It's that U shape that we talked about. My next step is going to be finding the vertex. And in order to find the vertex. We are going to go to menu. We're going to choose option 6. And then you might choose option 2 or 3, depending on if your graph has a maximum or a minimum. This one has a minimum. So I'm going to go to menu, number 6. Something happened there. Menu, number 6. And then I want either minimum or maximum. Again, we said this one has a minimum, so I'm going to hit number 2. Then I want to be on the left side of my function. Hit enter, because I'm already there. And you should see this change to ask for the upper bound. That means I want to go to the right side of my function. Enter again. Okay, and it gives us our minimum here. Negative 2.5, negative 2.25. Okay? So that's our vertex. So I'm going to write what that vertex is. Negative 2.5, negative 2.25. The next thing I want to find are my x-intercepts. That's really the other thing I care about. My x-intercepts, I can see where it crosses if I count in my graph over 1, over 2, over 3, over 4. Okay, sorry, it's blinking. So I'm at negative 4. Okay. Negative 4 and negative 1. Okay, so I'm just going to write those zeros. Negative 4, 0, negative 1, 0. So that's your last step for the calculator. Find x-intercept. Okay? Once I do that, I'm going to draw my actual graph. Okay? So I'm just going to draw a nice picture. I'm going to put my vertex at negative 2.5, negative 2.25. So vertex, negative 1, negative 2, negative 3, negative 4, negative 5. So, negative 1, negative 2, negative 3, negative 4, negative 5. Between negative 2.5 is going to be between negative 2 and 3. Same thing with negative 2.25. Between negative 2 and negative 3. So somewhere around here is my vertex. My x-intercepts, or my zeros, are going to be at negative 4 and negative 1. And then again, this one looks like a smile. Okay. So my graph doesn't have to be super great, just pretty basic. Okay? Alright, now, the sign of the leading coefficient. This looks like a smile. It's positive. Again, we'll skip increasing and decreasing. The other thing, I forgot to look at my y-intercept on my graph. My y-intercept is here. It's up 1, 2, 3, 4. Sorry about that. My y-intercept is at 0, 4. Again, that's from the calculator. I will also write that over here. And then the other thing we can tell right from this is that it is a minimum, right? That's our lowest point. The last thing we're going to do is increasing and decreasing. I'm going to draw that line through here. So I go from negative infinity. Remember, this is negative 2.5. It comes from here. Positive infinity. Same thing going the other way. Negative infinity. Negative 2.25. So looking between negative infinity and negative 2.5, my graph is going down. That's decreasing. Looking between negative 2.5 to infinity, my graph is going up. That's increasing. So it's negative 2.5 to positive infinity. Domain, if you look, it's on both sides, right? My graph is in both of these places. So my domain is from negative infinity to infinity, right? It goes all the way from here towards this side. My range is only between these two, negative 2.25 to infinity. And again, we're going to use that bracket instead of a parenthesis. All right, last example. I'm going to type in x squared minus 2x. So again, new document. All right. No, we don't want to save. We want to add a graph. X squared minus 2x. Enter. The first thing I do is find my vertex. Menu. 6. This one also had a minimum, a low point. I need to go to the left of my graph, hit enter. I need to go to the right of my graph, hit enter. My vertex here is 1, negative 1. That was writing. My zeros, my x-intercepts are 0 and 2, if you look here. So 0, 0, and 2, 0. So let's draw this graph really quickly. Vertex is at 1, negative 1. X-intercepts are at 0, 0, and 1, 2, 0. Easy enough. Then it looks like a smile. Then, final leading coefficient, again, like I just said, it looks like a smile, so it's positive. We'll skip increasing, decreasing. We did on x-intercept. Domain and range is last. Max or min? Again, this is another one that has a min. Alright, then. Same thing, draw your line. That was at 1. That's negative infinity to 1 to infinity. From negative infinity to 1, left to right, it's decreasing. Negative infinity to 1. 1 to infinity, it's increasing. Domain, negative infinity to 1, there's something between those pieces. 1 to infinity, there's something between those pieces. So I go all the way from negative infinity to infinity with my domain. Range has to do with the height. Negative infinity, I can draw the line across here. That number is negative 1 infinity. Where is my graph? Is it between here or between here? It's between negative 1 and infinity. So that is my range. Alright, that is it. This was a very long video with lots of pieces to it, but go ahead and work on the activity. There's 3 graphs to do.